friends. So we'll be working on basically calculations on how to determine the order of a reaction, the rate constant of a reaction, and the rate law of a reaction from a given experiment conducted. So if you look at this question, the question says the reaction of nitric oxide with hydrogen at 1280 degrees Celsius is, as you can see right here on the board, and the question was determine the rate law, the rate constant, the rate of the reaction when the concentration of NO is equal to 12 times 10 to the minus 3 molar concentration, and the concentration of H2 equal to 6 times 10 to the minus 3 molar what concentration. So these are the experiment, the data collected from the experiment. Now, in doing calculations based on this aspect, we need to be very, very careful, and there's a trick in it which I'll teach you. I'll explain better for you so you understand it. Now, mere looking at this reaction, one would think it will be a fourth order reaction, because the NO has a mole of 2, the H2 has a mole of 2. So the addition of the 2 plus 2 gives us 4. But it is not like that, because we have established the fact that the order of a reaction is determined by what now? By experiment, which is the rate law is determined by what? The experiment. So it therefore means that if I'm to solve this solution, it will be, first of all, what I do is I will write the rate of the reaction, which is R is equal to K, the concentration of NO, and H2, which is the concentration. Now I will label here X, I will label here Y. Really be that we have said that the order of a reaction is what is to be determined by experiment, and the experimental data was given to us right here on the board. Now we are going to be relating one of the experiments with the other experiment to see how we can compare and do the calculation. Now, in doing such a calculation, please be very, very, please follow me as please follow me swiftly. Now we look for scenario whereby we will try to relate any of the experiment. We will relate experiment 1 and 2. We will look for how, in a way that these two, they will be one of the reactant will be constant, will be kept constant, so we can determine for the what now, for the order of the other one. So if you look at this kind of reaction, experiment 1 and 2, the concentration of H2 is constant here, while here varies. So I can relate experiment 2 and 1 in order to get for my what, my get the power of NO, which is what, X. Why that of to determine for the data for the rate law or the order of H2, I'll look for where in NO we have two values that are constant or that are the same, so that I don't know, they can cancel out. If you check it, it will be experiment 2 and 3 here, which is these two that are constant. I will relate this and this in order to get from the rate of the what reaction. Exactly. So we'll move like this. So we experiment. So dividing experiment 1, or sorry, dividing experiment 2 and what? Experiment what? 1, which will now be R, which is the R2 is equal to the K constant and what now? Alright. Okay, so the initial rate of this reaction, which is for the experiment 2, we have it to be 5 times 10 to the minus 3 is equal to that of the NO, which is which K, and we have our NO here, which is 10 times 10 to the minus 3 raised to our X. Then we have our H, that of the H2, which is what? 2 times 10 to the power minus 3 raised to the power y, divided by that of 1.3 times 10 to the minus what? Minus 5. K here becomes here becomes 2 times 10 raised to the power 10. Okay, now when you look at this aspect here, we basically talk about, we said divide this experiment 2 and experiment 1. So we'll pick all the values of experiment 2 here divided by all the values of what? Experiment 1 from this is our watchword. So the rate of the experiment 2, which is what now? 5 times 10 raised to the power minus 5 is equal to K, the concentration of that of 10 times 10 to the power minus 3 x, and 2 times 10 to the power minus 3 raised to the power what now? Raised to the power y, divided by 1.3 times 10 raised to the power minus 5 divided by K, divided by what now? 5 times 10 raised to the power minus 3, which is the concentration x, and what now? 2 times 10 to the power minus 3 raised to the power what? Y. Now if you observe, we've already established that you will check each of the experiments, the two that are resembled or that are the same, so that they can cancel, so you can get for the other unknown. Now you just strike, because the same thing. So when you divide, here it goes away, here it goes away. So when you divide these two, you'll be having an approximate value of 4, which is equal to, now here divided, here will give us 2 raised to the power x. Now when you take the indices of this one, or the power of this one becomes 2 raised to the power 2 to give us 2 raised to the power x, so that x is equal to what? 2. Okay, now we'll now quickly move to, now we are working for the power of x of NO. Then we'll move to that of the power of what? Y. We'll check again. Here we will now say, let us dividing experiment what now? Experiment 3 with that of 2, experiment 3, and experiment 2 with experiment 2. So what do? We'll pick again 10 times 10 to the minus 5 is equal to K 10 times 10 to the minus what? Minus 3 raised to the power x divided by K, then which is 10 times 10 to the minus 3 raised to the power x, then that of the NO, which is what now? 4 times 10 raised to the power minus 3 raised to the power y, and 2 times 10 raised to the minus 3 out of what? Y. So remember that the constant of that of this one is 5 times 10 raised to what now? Minus what? Minus 5. So when you divide this, you'll be having 2. K cancel K. Yeah, they are also equal. Just like it was that of when we're looking for this other one, this first one that we did. So here becomes equal to what now? When you divide here with here, you have 2 raised to what? Y. And remember, any power here, the power of 2 here is what? 1. So y is equal to what? 1. Now from the question, so the rate law of that reaction now becomes A is equal to R is equal to K NO. Anywhere you see X now, you put power of 2. Anywhere you see Y, you put the power of 1, which you don't write. So it becomes H2. So this is the rate law for this reaction. Now to calculate for the rate constant, which is R, which is B now, R is equal to what? K NO raised to the power 2 and H2. What do? You make this rate constant the subject of the formula by saying K is equal to R all over NO raised to the power 2 and H2. Now in doing it, you can pick any of the values of the experiment, either experiment 1, 2, or what, or 3. Now, but we'll try to pick the data of the experiment 2, so we can have a concrete answer. So it becomes the rate. You pick any of the experiment, either you pick experiment 1 or experiment 2 or experiment 3. Anyone you pick, you tend to get a similar answer, but we'll try to pick experiment 2 for congruency. Is that clear? So it becomes the value of arrow from experiment 2 becomes 5 times 10 raised to the minus 5 all over 10 times 10 raised to the minus 3 raised to the 2, and that of H2 is 2 times 10 raised to the minus what? Minus 3. When you divide this with this, you'll be having 250, which is also equal to 2.5 times 10 raised to the power 2. And the unit for K here, alright. Now the unit of K is, because it is a third order reaction, the unit of K becomes per meter square seconds. Alright, we quickly move straight to the next question. To the next question, which is said the rate of the reaction when NO is equal to 12 times 10 minus 3 and H2 equal to 6 times minus 3. So what do you do? It's very simple. To calculate for C here, you just quickly move swiftly to say R is equal to K NO is equal to 2 and H2. Now you are looking for the rate now, the rate of this reaction. So you have your K from what you have from what you have determined through experiment to be 250 times the value of NO you were given now becomes 12 times 10 raised to the minus 3 raised to the power 2, and the value of H2 which were given to be 6 times 10 to the minus what? Raised to the minus 3. When you multiply all of them, you tend to get, alright, you tend to get 2.2 times 10 to the minus 4 molar concentration per second. So that's the final answer. So please, you have to go through them over and over again to understand them. We have shortcuts for them. So if you just know that that some cases where if you see a given experiment from a data from a given reaction, try to look at it. At what point do we have any of the reaction that is constant? If you can get any experiment that the two are constant, so you can get for the other one. In this case, now look at it. Yeah, they are the same. So it means you can get for the value of this one. Yeah, they are the same. It means you have to get for the value of what? H2. So we'll solve another question again to buttress more our point. Alright. Now this is another question too. Now this question you have it, which is from the experiment data collected. When you look at the second question here, it said from the experiment data collected at a certain temperature, determine the rate law and calculate the rate constant. The rate law and the rate constant. From there, we can also get the order of the reaction. And these are the data given to you. As I've already told you, if you should write it out like this, merely looking at this reaction again, you will say it is a fourth order reaction, meaning that the coefficient of this reactant here is 1, here is 3. But I've told you that you don't get the order of a reaction or the rate law of a reaction by just merely looking at a reaction. No, it is done by experiment, and the data are always given to you. So this is one of the major issues that students always have, that often encounter. But this video is going to help you to get off that puzzle or that dilemma. Now, if you write it like this, the rate of the reaction is equal to K, which is S2O4, which is 2. Here becomes X again, it becomes iodide ion, which is what? Y. So let us solve for such let us now. If you look at this question, we check at which of the place in which to get for the value of to get for the order of this reactant here, this first reactant here. What do? We check where this one, where at which point in which that of this one they are the same. And if you check, you will observe that it is experiment 2 and 3 because of this one. So the way you write them out, they will both cancel out. It's very simple. So what do? You will now say, let us, because this rate of this reaction is higher than this one, so we say dividing experiment 2 to what? To that of what? Now 2. Sorry, divided experiment 3 to that of what? 2. So what do we now do? It becomes very simple. Since you know that here they're going to cancel, so it means you have to relate this and this, which should now be what now? Which should now be 2.2 times 10 raised to minus 4 divided by what? 1.1 times 10 raised to minus 4, which is equal to 0.160 over 0.0810 raised to power what? Y. So we divide this, you have 2. When you divide this, you have 2 raised to power y. So it means y is equal to 1, meaning the order of this reactant here, one of the reactants here is what? Is 1. I have told you. Make sure that I didn't follow the long cut I did previously. It's for you to just relate it. When you're able to relate it, you know what to do. Now next again is to get for the order of this other reactant, which is the iodide ion. So you check again in this reaction again. At what point I'm to get for this now? So I'll check for this one. At which point are they the same, or are they at the experiments of either of 1 and 2? Are they that they are equal? You observe that it is experiment what? 2 and 1. Which at the end of the day they will both cancel out. So what do? You relate this and this. So you say dividing experiment 1 to 2, which will now be 2.2 times 10 to the minus 4 all over 1.1 times 10 to the minus 4 is equal to what? 0.034 divided by what? 0.017 raised by what now? Raised to the here ought to be x, so very sorry, x, so here becomes what? Y. So when you divide here, you get 2, you divide here, you get what? 2 raised by what? Y, and y again 2 is also what? 1. So it means now from the rate law now, you can say the rate law is now equal to what now? K, the concentration of what now? S2O4, X is 1, so just same thing. Why? That of the iodide ion is also what? 1. So it means the rate of this reaction, the order of this reaction becomes what? A second order, which is 1 plus 1 is 2. Why? They say calculate the rate constant. Now which is B now, the rate what? Constant. To calculate for the rate constant, what do you do? Simple. You just make K the subject of the formula by saying K is equal to R over S2O4 2 minus to the iodide ion. So I told you pick any of the experiments, alright? So that you pick any of the experiments, so you can either pick experiment 1, 2, or 3, you tend to get the same answer. So we'll pick from experiment 1 to determine the value of K. So it will be 2.2 times 10 to the minus 4 all over the concentration of S2O4 from the given data is 0.080. That of the iodide ion is 0.034. Now when you multiply and you divide, alright, when you multiply and divide, you tend to get it to be what now? 0.081, which is also equal to 8.1 times 10 so minus 2, and because it is a second order reaction, so what do you get? All right, because it's a second order reaction, you tend to get molar concentration raised to power -1, and it's per second, meaning per molar concentration per seconds. That's the final answer. So I hope this video will go a long way to help you, and if there's any question you tend to have to ask, feel free to ask me by all right.